Welcome to highschoolmaths.co.uk. Today we're going to be looking at function notation, and we're going to focus on how we use function notation as a kind of shorthand. So we've got a specific example here we're going to jump straight into. It's f of x equals 3x plus 4. Now what this is kind of equivalent to is y equals 3x plus 4. The reason function notation is useful is when we want to replace x with a specific value, we would have to say let x be this value when y equals da 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 da, and we'd have to write a big sentence, whereas function notation cuts that down a lot. So for example here, if we want to replace the x in this function with the value 1, all we have to do is write f of 1, and that tells us that we're replacing the x, which is within the bracket in the function notation, with a 1. So you can see that here, f of 1 would be 3, so wherever we see an x, 3 times 1, or 3 bracket 1, plus 4. All we've done there is replaced any x's that we see in our function with the value inside the bracket. So if the value is 1, we replace all the x's with 1. Sometimes there can be more than one x, so you'd have to replace it more than one time. So this example here, that, like we were talking about before, that means when x is 1, f of x equals, or f of 1 equals, 3 times 1 plus 4. So 3 times 1 plus 4. 3 times 1 is 3 plus 4, which is 7. So let's have a look at how that actually works in some examples. So there's a couple of common examples that you'll see. The wording in the questions is quite different, so you have to look out for that. But let's start off with this function here, g of x equals 3x minus 2. And we've got 3 different values we want to evaluate. So g of 4 first of all, so we'll do a. G of 4 equals, so we're taking this function and what we're doing is replacing the x with a 4. Wherever we see an x, we replace it with a 4. So it's 3 times 4 minus 2. So 3 times 4 minus 2. 3 fours are 12 minus 2, which is 10. It'll be the same thing if it's a negative number, just be a little bit more careful. So g of negative 3, that's going to be equal to, so it's 3, just replace that x here with negative 3 minus 2, so that's 3 times negative 3, which is negative 9, then the minus 2 at the end, minus 9, negative 9 minus 2 is negative 11. And the last one, we're replacing the x with a different letter, so instead of having g of x, we're going to have g of t, so g of t, instead of having this x here, we're going to have a t, so it's 3t minus 2, and that's all you can do with that. So this is just a simple substitution of t into the function. Now, example 2 is looking at a slightly different wording of the question. You have to be really careful because it is only a very slightly different wording and it looks really similar. So you've got a function here, h of a equals 3 minus 5a. And we want to calculate a when h of a equals negative 7. Now this is different from what we had above. Above we had evaluate g of 4, g of negative 3. So the value was inside the function, inside the bracket. Here it's actually telling us the function is equal to negative 7. Now h of a is this part of the function. It's saying that this whole thing, this function, is equal to negative 7. So what we're going to do is we're going to replace this first part here with negative 7, and then the right hand side of the function stays the same, and essentially what we get is a nice simple equation to solve. So we try and balance this out. If you're more comfortable flipping the equation, you can. Here we're taking away 3 from both sides. This is a positive 3, so we're taking away 3 from both sides. That's going to give us negative 10 equals negative 5a. And then we're going to divide by negative 5 on both sides to get 2 equals a, or a equals 2. Same idea with question B. Again, we're working with h of a equals 18, so we replace the h of a part of the function with 18, and 18 equals 3 minus 5a. So we're going to take away 3 from both sides again. That's going to give us 15 equals negative 5a, and then just divide by negative 5 to get negative 3 equals a, or a equals -3. Now, look at the wording for those questions. You can see there is a difference, and you've got to be able to spot that difference. Sometimes both of these kind of things come up in exams, sometimes it will only be one part of it. So watch out for that, and know the difference between the two. For the first one, this one here, you're taking the value within the function and substituting it into the function. Here, you're taking the actual value for h of a and replacing the left-hand side of the equation with that value, and then solving like it's an equation. Okay, so two different methods. Hopefully you found that useful to see the difference between the two, and if you want more videos, please visit highschoolmaths.co.uk. If you did like the video, don't forget to click the like button and subscribe, and please remember to share the video. Thanks for watching, and have a mathemagical day.